Compound interest is one of the most important concepts in finance. Albert Einstein reportedly called it the eighth wonder of the world. Whether or not he actually said this, the sentiment is accurate. Compound interest can turn modest savings into substantial wealth over time, or turn small debts into overwhelming burdens. To understand compound interest, we first need to understand its simpler cousin, simple interest. Let's start there. Simple interest is interest calculated only on the original amount invested or borrowed. This original amount is called the principal. The interest earned each period remains constant because it is always calculated on the same base, your original investment. The formula for simple interest is straightforward. Simple interest equals P times R times T. P is your principal or initial amount, R is the interest rate expressed as a decimal, and T is the number of periods, usually years. Let's see this in action. Say you deposit $5,000 into an account that pays 6% simple interest per year, and you leave it there for 4 years. Each year you earn $300, which is 6% of $5,000. After 4 years, you've earned $1,200 in total interest. Notice something important here. The interest earned is exactly the same every year, $300. That's because simple interest always calculates on the original principal, never on the accumulated balance. This is the key limitation of simple interest. Now let's talk about compound interest. Compound interest is calculated on the principal plus any interest already earned. In other words, you earn interest on your interest. This creates a snowball effect where your money grows faster and faster over time. The formula for compound interest is A equals P times the quantity 1 plus R raised to the power of T. A is your final amount including all interest, P is your principal, R is the interest rate as a decimal, and T is the number of periods. Let's use the same example. $5,000 at 6% interest for 4 years, but now compounded annually. In year 1, you earn the same $300 as with simple interest. But in year 2, you earn 6% on $5,300, not $5,000. That gives you $318, an extra $18. That extra $18 might seem small, but notice how the interest earned grows each year. By year 4, you're earning $357.30 in interest compared to the flat $300 with simple interest. The gap keeps widening. After 4 years with compound interest, you have $6,312.38 compared to $6,200 with simple interest. That's $112.38 more, earned by doing nothing except letting your interest compound. And this is just over 4 years. The real magic happens over longer periods. This graph shows the dramatic difference between simple and compound interest over 20 years. The blue line shows simple interest growing in a straight line, while the green line shows compound interest curving upward, growing faster and faster. Notice how the gap between them widens significantly after year 10. The difference between simple and compound interest becomes dramatic over longer periods. This is because compound interest grows exponentially. It curves upward, while simple interest grows linearly in a straight line. Let's extend our example to 30 years. After 5 years, the difference is just $191. After 10 years, it's $954. But look what happens after 20 years. The gap is over $5,000. And after 30 years, the compound interest account has over $14,000 more. After 30 years, the compound interest account has nearly $29,000, more than double the simple interest account. Your original $5,000 grew by over $23,000 in interest alone. This is the true power of compounding. This is why starting to save early matters so much. A 25-year-old who invests $5,000 and lets it compound for 40 years will end up with far more than a 45-year-old who invests $10,000 for 20 years, even though the older investor put in twice as much money. Time is your greatest ally. So far, we've assumed interest compounds once per year, annually, but interest can compound more frequently, semi-annually, quarterly, monthly, or even daily. And here's the key point. The more frequently interest compounds, the faster your money grows. Each time interest is calculated and added to your balance, that new amount starts earning interest too. The formula adjusts to account for compounding frequency. We divide the rate by n, the number of times interest compounds per year, and multiply the time periods accordingly. This gives us the precise final amount for any compounding schedule. Here's $5,000 at 6% annual interest for 10 years with different compounding frequencies. Annually gives you about $8,954. But daily compounding gives you $9,110, about $156 more. The difference between annual and daily compounding might seem small on 5,000ers, but on larger amounts and longer time periods, it adds up significantly. This chart visualizes the impact of compounding frequency. You can see the final amounts increase as we move from annual to daily compounding. This is why banks advertise their APY, annual percentage yield, which accounts for compounding frequency, rather than just the nominal interest rate. Here's a useful shortcut for estimating compound interest, the Rule of 72. To find how long it takes to double your money, simply divide 72 by the interest rate. It's remarkably accurate for interest rates between 6% and 10%. Let's see it in action. At 6% interest, divide 72 by 6. Your money doubles in about 12 years. At 8%, it's 9 years. At 12%, just 6 years to double. It's a quick mental calculation that helps you understand the power of different interest rates. Now, here's the crucial flip side. Everything we've discussed applies to debt as well as savings. When you borrow money, compound interest works against you. It can be your greatest enemy just as easily as your greatest ally. Credit card debt is particularly dangerous because it compounds on unpaid balances, often at rates of 20% or higher. Using the Rule of 72, at 20% interest compounding monthly, debt doubles in about 3.6 years. A $5,000 credit card balance left unpaid would grow to roughly $10,000 in under 4 years, even without any additional purchases. This is why paying off high-interest debt is often the best investment you can make. Think about it. Eliminating a 20% debt is equivalent to earning a guaranteed 20% return. No investment in the stock market can guarantee that. So what are the practical takeaways from understanding compound interest? Let me walk you through the key insights that can help you build wealth. First, start early. Time is the most important factor in compounding. Starting 10 years earlier can make a bigger difference than doubling your contribution. Remember our example of the 25-year-old versus the 45-year-old. Second, be consistent. Regular contributions combined with compounding create substantial growth. Even small amounts add up when given time to compound. Consistency beats sporadic, large investments. Third, mind the rate. Small differences in interest rates matter more than you might think over long periods. A 1% higher return compounded over 30 years makes a significant difference in your final wealth. And fourth, avoid high-interest debt. Compound interest on debt erodes your wealth just as effectively as it builds it on savings. Pay off high-interest debt before focusing on investments. Compound interest is not magic, but given enough time, it can produce results that feel like it. Whether you're building wealth or paying off debt, understanding this concept is fundamental to making smart financial decisions. Start early, be consistent, and let time do the heavy lifting.